10 cans, of which 3 contains pumpkin puree. Okay. If a group of 4 cans is randomly selected, okay, so we have 10 cans. Out of
Mm,
these 10 cans, we have 3 pumpkin puree
mm,
and rest others. I can write rest 7 others cans. Out of these, we have selected 4 cans randomly.
mm.
What is the probability that the group includes the 3 cans containing the pumpkin puree? It means what is the probability that in these randomly selected 4 cans, you will have these 3 pumpkin cans also? Are you getting the question?
Yeah.
So what is the
Mm.
probability that in this 4 randomly selected cans, 3 pumpkin cans is already included?
I see. Interesting.
Should I discuss? Can I start?
Okay. Oh, sure.
See, okay. So basically, we have to calculate the number of sample space first. Can we calculate the
Mm.
number of sample space? It means out of 10 cans, I have to select 4 cans. In how many ways I can select them?
Okay. Okay, I get it. Yeah. Okay.
Should be 10C4. Do you know how I have written this?
Yeah, because out of
Should
the
I?
10 you choose 4. Yeah, that
Yeah.
part I get. Yeah. And then now you
Basically
multiply by 4
NCR.
C3.
Wait, yeah. NCR gives us the number of selection, isn't it? So we
Mm.
have to select 4 cans. Okay, out of this 10 cans. So this NS is number of sample space. What should be the number of favorable event? I want that number of cases in which these 3 pumpkin puree is already included. How we can solve this? How we can find
Mm.
in how many case it will have. Okay. So how we can perform this task, that's important. So what I will do, I will think in this manner. See, I have this 3 pumpkin cans and I have to select
Mm.
3 pumpkin cans. So in how many ways
Yes.
I can select them? So 3C3. Out of 3, I
Yes.
have to select all of them. So 3C3. And
Correct.
I have to select one more. See, I want total 4 cans. 3 I have
Mm.
already selected. So I need one more can to be select. And that
Correct.
selection have to be done from this 7 others. So it should be done in 7C1 ways, isn't it?
Yes. Yes.
And they should be multiplied because we have to select 4 cans. We don't have option here. We are bounded. We have a compulsory condition that we have to select 4. So 3 selected here and 1 is getting selected here. So they should multiply to get the total number of cases. So 3C3 is 1 and 7C1 is 7. Do you know how I have written this quickly? Do you know NCN, NC1?
Yeah. Yeah. NCN will always be 1, and then
Okay.
NC1 will always be N. Yeah.
Okay.
That
Tell
much I
me.
know.
Okay, let me summarize. NC0 is what?
NC0.
Is it defined or not?
I don't think it exists. Is it 0? It's
You have to
basically
tell
0
first.
because, I mean, the way I'm thinking about it is choose 0 out of N.
Yeah.
So,
So
0
that's the
possible
one
ways to do
way.
that.
That's the one way. That's a concept. Suppose you are offering me sweets and I have selected nothing. That's
Yeah.
also a way.
Hmm.
You
Yeah,
know,
I see. I see.
in Jain
Yeah.
community, there are two.
Okay.
You know, Jain community. They have
Yeah, yeah, yeah.
two kinds of follower. One is who says white cloths are their cloths. They are called Swetambar. The
Uh-huh.
second one they are called Digambar. They say
The number. Okay.
directions are their dress. or cloths.
Oh, wow.
Direction. So they don't have any cloths on their body. They say that these directions are their cloths. So that's also a way of dressing. That is
Interesting. Okay.
NC0 is 1.
Mm,
You are selecting nothing. That's also a way, isn't
I
it?
see.
Okay. Next,
Yeah.
NC1 is N. You know this.
Yes.
NCN is also what? NCN is
NCN is also 1.
correct. It's 1. Very good. So in this way, we have 1 into 7. Okay. So what should be the probability? So probability of event E should be equals to N of E
Yes.
upon N of S. So N of
Correct.
E is 1 into 7 upon
Yes.
10C4. How we can
Yes.
calculate this? So we should have factorial 10 upon factorial 4 into
Mm,
factorial 6. So it should be
yes. Correct.
10 into 9 into 8 into 7 and factorial 6 cancel out. And this should be 4 into 3 into 2. Right?
Okay.
This 4,
Yes.
2, 8, 8 cancel this 3, 3. So 7 threes are 21 and 10, 210. So it should be 210 and it should be 1
Yes.
over
31
30.
over 30. Okay.
Any doubt?
Oh, no, I think it makes sense. Yeah. So far, so good.
Listen this one. Questions are
Yeah.
okay.
Yeah. Now,
Okay.
yeah, yeah.
The probability that Maria will eat breakfast, so probability of eating breakfast
Mm,
on any given day is zero point 0.5. The probability that the Maria will wear a sweater
mm.
on any day is zero point 0.3. The two probabilities are independent of each other. What is the probability that Maria eats breakfast or wears sweater? That's the question. Please try.
Breakfast or wear sweater. Okay. So essentially, then we'll eat is 0.5, will wear is 0.3. Eats breakfast or wears a sweater.
See.
I see.
Do you know?
Oh,
Yeah.
yeah, you know, you were saying so. Yeah, you were saying.
Do you know the probability of A union B? Do you know any formula for probability of A union B? Or do you know the
Formula, I don't.
okay, the concept or number of
Yeah,
elements in A union B?
yeah, that part I understand. Yeah, what it is. Yeah.
It's the number of A union
So
B. It's a standard
A
formula it
union
has.
B is just number A plus number B
So,
minus N intersection B of A intersection B. Yeah.
correct. Similarly, for probability also you can have probability of A,
Mm,
probability of B, minus probability of A intersection B. How we can get this formula? If you just divide both side by n of s, it will convert into the probability. See, this will be n of A upon n of s. This will be n of B upon n of s minus this should be n of A intersection B upon n of s. So they converted into the probability. This becomes the probability of A, this becomes the probability of B, minus this
mm,
becomes the probability of A intersection B, and this becomes the probability of A union B. Is it okay?
yeah.
No. Please work. So we have the probability of A. Suppose this is the
Mm,
event A and this is the B. So you know this is the zero point 0.5 plus
yes.
0.3. But what it
Yes.
should be? A intersection B. This is given.
Mm.
What it should be?
A intersection B 0. Oh, so it's a
0.
0.8 answer. Okay.
0.8.
I mean,
If
that's
you
okay.
write
Oh no, but it
0.8, then becomes 0. The overall answer becomes 0.
yeah, yeah. Let's see. Wait, 1 minute.
Let's see. Do you see?
Okay.
We have given that A and B are independent event. What does it mean?
Independent event. That means they're not dependent on one
Yeah,
another in a way.
correct,
Yeah.
correct. That's the explanation in language. What's the mathematical condition? What's the mathematical?
And A intersection B will be 0.
No, that is not the meaning of
Oh,
intersection. That is not the meaning of independent. See, wait.
wait,
There is a
really?
very important difference. Many student gets confused here. Many student
Okay.
being
Because
independent and being
hmm,
no intersection. It's entirely different. See, suppose you are going to a movie
hmm,
and I am also coming to Singapore for in that theater. Both are independent, right?
yeah,
Agree?
I agree. Yeah.
But it may be that we both coincide at somewhere.
Hmm,
It possible or not?
possible, very possible.
Possible. So being independent is different thing.
Hmm,
This A intersection B, it means what is the common in both A and B? Suppose I'm in also Singapore or you are in India. Suppose your mother is in India, right? So suppose you
hmm,
are also in India. So your
okay,
going to some mall is independent, and my visiting of that mall is also independent, isn't it? But
correct.
it may be that we both coincide at somewhere in the mall or not.
Yes,
Have you understood? Being independent is different thing, and being uncommon or not common
it's
intersection
different
zero
thing.
is different thing, entirely different thing.
I
So
see.
independent event means the probability of A intersection B is probability of A into probability of B. That's the mathematical condition.
Oh, I see. Okay. Hmm,
Okay. So you can say that this should be zero point 0.3 into zero point 0.5. Now please calculate what's the answer. See, I have selected this question. Otherwise, this is a simple formula putting question. But I have selected this one only to explain this one. I have a doubt that you may do a mistake here. That's why I have included
hmm,
this one. Okay, so
of
please
course, of
calculate
course.
the answer. Should be zero point 0.8 minus 0.15.
Hmm.
What it should be.
It will just be 0.65. Okay, makes sense. Hmm.
No, please take. I will send you this PDF. So you will have some questions for your homework. This one, and
Sure.
I have some questions left about this one. And now I am discussing one question from my side directly. Now, this is a very important question. Very important. So important that it is asked. It is asked from ninth standard to your higher end examination.
Sure.
What is the probability?
Hmm.
With the probability of having 53 Sundays in a leap year.
Uh-huh.
What is the probability of having 53 Sundays in a leap year? If we have a leap year, then what is the probability that it may have a 53 Sunday? This is so important
Hmm.
question. It is being asked from ninth is not, I can say from seventh or sixth standard to your graduation and post graduation level.
Hmm.
So
So
guys,
can I
see,
try this one, sir? This one I think I can do quite. I
yeah,
should be
please
able to
do,
do.
please do, please do, please do. I have remembered the answers. See, this is repeating so many times. I know the
Okay.
answer.
Give me exactly 2 minutes. This one I think I know the
Okay, okay,
trick
okay.
now.
Please
I
try, please
understand.
try.
Yeah, just 2 minutes. Oh wait, sir, is it 2/7?
Should be 2/7.
The the reason why I can explain this one as well. So you have 366 days. So out of
Yeah.
those 366 days, you'll have 52 weeks and 2 extra days. So now in those 52 weeks, you're guaranteed 52 Sundays, right? So now that is gone. Now in
Yes.
those 2 extra days, you will have seven possible combinations, correct?
Correct, 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 correct,
So
correct,
then
correct.
out of that, there are only two combinations which are Sunday. So Sunday, Monday, and Saturday,
Yes.
Sunday. So that's why it's 2 or
Yes,
7.
yes.
Yeah.
Very good. So,
Yeah.
okay. So we will,
This one makes sense.
yes, yes.
Yeah.
In the next class, we will see some questions from this side, from your ESAT also, and we will continue
Sure.
our physics discussion also.
Of
Okay?
course. Sure, sir. Sounds good.
Okay.
Perfect.
Okay.
Yeah.
Okay.
Thank you so
Thank
much,
you.
sir. Thank
Thank
you.
you.
Goodbye.